Hello, this is Mrs. Hickman, and in this video we're going to be going over the indefinite integral and how to verify a derivative with its antiderivative. So it's fairly simple. Indefinite integrals are much like that of in differential equations, where it's the family of all derivatives. So for example, if you had a constant, that's going to be that's going to be the c. So like the c could be a 4, but we don't know that, but that's what the c is going to denote. Okay, because all we can do when we derivative, so if this was like a 4 under here, the only thing we could do is do a 4x. Well, we don't have anything for a constant, so that's why we make that c. So to find the indefinite integral of this, you just differentiate. So you have x cubed over 3 minus sine x. So the antiderivative of sine x is going to be negative cosine x. So your final answer is going to be x cubed over 3 plus cosine x plus c. If you're confused how I got cosine x, what I like to do, I just like to do the derivative up here, because I know the derivative of sine x equals cosine x, but the derivative of cosine x is negative sine x. So if I'm integrating a sine x, it's going to be a negative cosine x. And if I'm integrating cosine x, it's going to be a positive sine x. Okay, let's do this one. So we're going to have 3x to the 6 plus 1 over 6 plus 1 minus 2x to the 2 plus 1 over 2 plus 1 plus 7x to the 1 plus 1 over 1 plus 1 plus x plus c. Okay, not too bad. This one requires a little bit of simplification because it looks kind of scary, but it's not really that scary. So let me show you what you do. We're going to break this up. So we're going to say this is t squared over t to the 4th minus 2t to the 4th over t to the 4th dt. Okay, so t squared over t to the 4th is 1 over t squared, 1 over t squared minus 2 dt. To make this easier to integrate, I'm going to make that t to the negative 2 minus 2 dt. And that's going to be t to the negative 2 plus 1, which is going to be t to the negative 1 over negative 2 plus 1, which is negative 1 minus 2t. So plus c. So your answer is going to be, bring that negative up here, negative 1 over t minus 2t plus c. Okay, this one. Okay, so this one, you can't integrate it how it is yet. Anyway, you'll see another way. It's going to be substitution, but we're not going to do this one by substitution. We're going to use trig identities to do this. So, I see cosine x over sine x. I know that is something that sounds familiar. Hopefully it sounds familiar to do. Then you got 1 over sine x dx. Cosine over sine is cotangent. 1 over sine is cosecant. Okay? Now this may look a little different than you're used to, but this is a derivative of something. And if you can remember, cosecant x, cotangent x is a derivative. You're just seeing it backwards. So the antiderivative of cosecant x, cotangent x is negative cosecant x plus c. And there you go. Okay, next I believe we're going to be verifying So we're going to be verifying that this integral is, or this is the, what are we going to be doing? Yeah, we're going to be using differentiation to verify the antiderivative formula. So differentiation. You cannot do differentiation on this side because this is a derivative. So it is this side that you do the differentiation to. So let's get started. So the derivative of cosecant of u is going to be negative cosecant u cotangent u. So this negative's from there. Which is going to be cosecant u cotangent u. And that's what you got. That's how you verify. This one over here. How do I do that one? Well, here's a little hint. D over dx a to the u equals a to the u ln of a. So, to do this one, you're going to find the derivative of this. So let's look at it like this. So we have 1 over ln of 5 times 5x. Well, 1 over ln of 5 is a constant, so you don't look at that. You're looking at this. So you got 1 over ln of 5 times 5x. Here we go. 5x. So a to the u, so 5 to the x times ln of 5. Okay, well what happens here? This and this cancels out, so you're left with 5 to the x. And that is how you do indefinite integrals and how you use differentiation to verify the antiderivative formula.